So measurement always causes system to jump into an eigenstate of a dynamic and variable being measured. It is said by Dirac. So what do we mean by this? Suppose before the measurement is happening, the state is in linear combination or sometimes referred to as superposition. So before we make a measurement, it is assumed that it is in some superposition and can always write this as R. Right. So before the measurement, the state is R. Now making some measurement. It jumps to this state. Jumps to the state A prime with some probability coefficient. So till now we have only referred to this as some complex coefficient. Now we are postulating that the square of this, let's say, probability of getting the state A prime is square of this, which is C prime square. Sometimes referred to as probability okay, but what we are referring to here is not a single measurement. But rather multiple measurements on multiple isolated systems. So let's say I have a state alpha here, there is state alpha here, and all infinitely many isolated systems in different boxes, let's say. And if I make measurements on each of these boxes separately, then the outcomes will be defined like this. So let's say if I have a state alpha with a linear combination like this, A1, A prime, Then if I have a collection of such ensemble, then this ensemble is referred to as pure ensembles. Pure ensemble. Because each state in this ensemble is always represented like this, nothing else. All of the states can be written as only this linear combination, nothing else. These will be some constants and not always changing. Or here, let's say this is 1 by 3, 1 by 3, or 1 by 3. This will be here also again 1 by 3, 1 by 3, and 1 by 3, and not something else. So these ensemble, this collection of all these states will be called pure ensembles. Now we define something called as expectation. We are defining it as something like this. So, as we discussed, that expectation value is not something that we get in one single measurement, but there are multiple measurements on multiple isolated same kind of system. How can we get something like this from here? So let's say we can always exploit the identity right? So this is a number, this is a number, and since this is eigenstate of this, so we'll get a number out of this. Let's say this AJ. The eigenvalue, and this will give us chronicle delta. So this chronicle delta will kill this sum, and only will be left with, instead of two sums, we'll have only one summation. And let's say I is equals to j, so I'll change all the indices j to I, and this will be ai, alpha ai, alpha I, alpha ai alpha. This will become square. So expectation value is summation of all such kind of terms, which looks like kind of an average because alpha is normalized. So this is your probability amplitude, and this will be the measurement outcome. It is also natural to see that probability amplitude is positive, and summation of all such terms should be 1. We should want that summation of all the probability should always be 1. So this also sums to infinity. It is generally expected from summation of probabilities. So this is also satisfied here. So it's a reasonable postulate.